Okay, good morning. This video is going to be in regards to mechanisms of self-defense, the immune system, and I've written down a few points. As always, I want you to remember that with all due respect, you need to, it's advised to read the book, even the pages that are not going to be in the exam. I think it will do you good. You have the presentations. Sometimes you have links and this video. So the purpose of the video is to just emphasize a few points, and by doing this, by no means that means that these are the only issues that are going to be in a quiz or an exam. Alright, legal issues aside, I think that we start with the major point of understanding that immunity is divided into two systems and one major reaction or process that is the result of those two. So we have the innate immune system, we have the adaptive immune system. First of all, it's important to understand that they collaborate, or rather activate each other. No matter where the story starts, it usually ends up with both the systems activated and with inflammation. So there's a relationship between them, and while they have different tools and so-called weapons, mechanisms of defense, they have ways of interacting with each other, and it seems that the immune system is built in a way that no prisoners are taken, and so to speak, and B, the reaction is massive, can either be non-specific or specific depending on what level we're talking about and what exactly entered the body or is attacking the body, so to speak, threatening the body. But you know, it seems like the immune system almost does not spare anything when such a thing happens, because if you went over the book and over the presentation, you saw that you know, that can lead to death, which obviously is the number one concern. Any organism's first concern is survival, and we have to understand that. Alright, so if we're looking at the major characteristic of the innate system is non-specific. It's built on what we call physical barriers that are localized or located in major areas of entry to the body. So anywhere basically that the possibility of contact with the environment exists, and thus the possibility of something coming in from the environment, that's where you're going to find, mostly going to find the innate immune system. And when we're talking about physical barriers, that means either chemicals or actual barriers that slow down and hopefully prevent the entry of the foreign body. So that can be mucus, that can be levels of pH, it can be chemicals that are secreted, the skin itself, so actual cells, and so on and so forth. The idea is to trap the foreign body and make it die, and at some point to get rid of it. So for instance, when you sneeze, you're actually removing trapped foreign bodies from your nose. Let's see. So we talked about that. Between the two systems, the most natural and immediate outcome is inflammation. Before this course, it would be likely for you to think that inflammation is a bad thing. So I want to emphasize this, and I also emphasize this to the undergrad students when I gave you a guest lecture in Kayla's course. Inflammation is a natural, good response or process when it's regulated and when it's controlled. It's when it's not regulated and when it gets out of control that the major and dangerous effects of it may occur. One of the things that we've seen, if you read already the presentation about cancer, is cancer. So, and this brings me to a point that I think that I've mentioned before, and if not, I'm mentioning it now, and I'll definitely mention it again because it's a major principle to understand. Don't look at things as bad and good. Bad and good is relative to what's going on at the same time. So we see here a process that is natural, that is part of our defense. It's part of making us survive. That is awesome when it works. Hence, as we said, regulated and under control, and can lead to death when it's not. So is inflammation good or bad? It can be both. Okay, it's not this one or the other. It's about the extent of the phenomenon. Inflammation, by definition, is a response to injury. Hence, you can be sure that if you have inflammation, you have some kind of level of injury. What level? We've seen in the first week and chapter that there are different levels of injury, right? And of course, the inflammation and its extent and its kind will result from the kind of injury. Inflammation is a process of the blood tissue. In case you don't know, by definition, blood is the plasma is a tissue. So that's where it's going to occur. So if you're looking for inflammation, where are you going to go to? To the blood. All right. The blood tissue, the plasma tissue, has all the perfect conditions to conduct inflammation. It has nutrients. It has fluids. It connects with the surrounding. It has multiple kinds of cells in it. It can be stopped or slowed down. It could be fastened. It has oxygen supply. You name it. You name it. It's truly the perfect setting for inflammation. We divided inflammation into acute and chronic. Obviously, the difference is not only time, but also the severity of the process. So when we're talking about chronic inflammation, the outcomes are usually more severe, and chronic inflammation can lead to acute inflammations here and there in different systems. When we're talking about inflammation, we're talking about two mechanisms or gross mechanisms that can lead to inflammation. The one that is emphasized the most in this chapter naturally is immune-based, meaning that a foreign body has entered the body, and by definition, a foreign body is anything that is in the wrong place at the wrong time. Sometimes it also can be part of the body. although that is rare. So a foreign body has entered the body, and either the innate immune system encounters it, or the adaptive immune system encounters it, and a cascade, a word that we're going to use so much, because if you ask me, one of the words that characterize us as humans is cascades. Almost everything is cascades. So a cascade of reactions according to the stimulation starts going on, and at the end you get an inflammation. In this case, the immune response can be either by direct contact with that stimulation, with the foreign body, with the threat, or it can be chemically induced, meaning that that foreign body is influencing cells, even not of the immune system, to secrete signals, chemical signals, sending, alerting the body and asking for help, and then the immune response reacts. The second mechanism is mechanical, which is very, very, very relevant to exercise, because it's a major, if anything will cause this kind of inflammation, it's exercise and any kind of physical activity. Usually overuse of certain movements. When certain movements are done and cause high levels of friction naturally turns into heat, and heat kills and burns cells that react in inflammation. And when the inflammation is reacted, then the immune system is part of it. So exercise is definitely a cause of inflammation, and you have lots of inflammations right now in your body. They're just controlled, so they don't lead to something severe. One of the amazing phenomena that we see, that it's up to the cell to decide if it wants to live, and might be affected, or to die. So in certain circumstances, the cell decides to commit suicide and die, and not let the attacker flourish. So it's like, if I'm going down, you're going down with me, and that happens. It can happen to a single cell. It can happen to a whole tissue, and usually it doesn't happen at the level of the organ. That would be problematic for us as humans. The adaptive immune system, although we'll talk about that in length and depth a bit more later, the major principle is that it is able to produce what we call memory cells, but it also relies heavily on encounters. You have to encounter the threat in order to initiate usually that system. That means that the system wants to be almost everywhere and all the time. So the bloodstream is perfect for that. The bloodstream and the lymphatic system is perfect for that, because it has circulation, and that's why you're going to find a lot of the immune system cells, what we call white blood cells, right, in the bloodstream. Okay, when we're talking about these abilities, we're talking about what we call plasma proteins, that are the ones that are part of the cascades. cascades in general, you'll see that are governed by proteins. And I'll just say now, and I'll probably say it again because it's a major principle that you have to understand. When you're talking about protein, you're talking about protein synthesis. When you're talking about synthesis, you're talking about genes. You're talking about genes, you're talking about genetics. There's no way to avoid it, and it's a major issue. Alright, so we have three major pathways in regards to plasma proteins that are broken down in the presentation. We have the complement cascade or pathway. By the way, pathway and cascade are almost the same. We have the clotting, and we have the kineme. This is where I want to stop for a second and talk to you and teach you a major principle in the body. There are substances / molecules, atoms, that are very potent. And it's not bad and it's not good. It is what it is. But you have to understand that the more reactive a molecule is, it's great when it's confined or when it's within a reaction, and it can have amazing results for you. But those molecules, when they are left alone, without a chaperone, without being confined to a very specific area where they can't interact with other molecules without regulation and control, those two words again, they are as harmful as it gets. So you enjoy their potency when they are on your side, but when they're left alone, not a good idea. So plasma proteins are exactly that. They're very potent. So their normal or common situation would be to be inactivated. You do not want these guys, so to speak, walking around the blood when they're activated. When they're activated, they're going to react. If they're going to react, they're going to probably do more harm than good, unless you are attacked. So most of them have to be activated first, and that's a good thing. They react by activating each other. So it might take a few phases until the endpoint is reached and the actual protein that you want to attack the foreign body is activated. So obviously this has disadvantages and advantages. The disadvantages are that it takes time and a lot of reaction and a lot of factors until the actual attacker or defense protein is activated. What are the advantages? This is a safety mechanism. You do not want these proteins activated for any reason besides the true threat to the body. So you have multiple defense mechanisms. Alright. Let's see. Obviously, once again, the amount of these proteins is regulated genetically. And when I say the word genetically, genetics, biogenetics, genetic expression, gene mutations, that means that you can have the right amount of proteins synthesized. You can have them down-regulating, meaning that you'll have less than what you need, and can be upregulated and you'll be overexpressing it. Obviously, hemostasis is the best thing. There's a certain amount or concentration of every protein that we need in order to function normally, but mistakes in genes or changes to genes may change the outcome. When we're talking about chemical mediators or chemical signals, a very potent and common family of molecules are the cytokines. Cytokines are key factors in inflammation, and they can work both ways. Some promote inflammation, and some decrease inflammation. So we have pro-inflammatory cytokines, and we have anti-inflammatory cytokines. Which brings us to talk about mast cells. Mast cells are a very unique and important kind of cell. They are very common in the body, relatively, and they are the ones that release cytokines. And this comes to show us the interaction with the environment and the cells within that environment. Just as an FYI, a lot of times, especially athletes probably know this, and of course sick people that have experienced inflammation. One of the major pro-inflammatory factors is called histamine. So in order to prevent inflammation or to decrease its outcomes, you give people antihistamines. So you've probably already heard those phrases, and if not, you might hear those in the future. Right. When we're talking about the white blood cells, we're talking about high specificity. We talked about those memory cells. Every encounter with a new threat causes the adaptive system to memorize or remember that encounter and the specific characteristics of that threat, meaning the proteins that threat has on its surface. And then by changes to genes and gene expression, you produce the proteins needed for white blood cells to attack and kill and neutralize that threat. So white blood cells are highly specific, but they interact with each other to kind of tell each other in a way what the threat is and initiate a massive response. One of the things that characterize inflammation is that part of the response and the ability to effectively influence the result, meaning we want a good result, right, is the ability to keep that inflammation local. We don't want it to spread. That means that we want to slow down blood flow in the area. We want to confine it to the area, and being able to do that is important, because it keeps the reaction as small as possible. B, it keeps the inflammation from spreading. And when inflammation spreads, it's easy to lose regulation, and it's easy to lose control, and if you remember, that's something that we do not want to lose. Let's talk about healing. We said that inflammation is a response to injury. Wounds are part of injury. We tend to think about wounds as something outside the body. We're used to seeing a scratch or, more than that. But there's also wounds within the body. Obviously, the level of healing can go from no healing to partial healing to complete healing. When complete healing has been achieved, it is called resolution. If you did not achieve complete healing, meaning that the tissue, the wound, is completely repaired and healed, you did not achieve resolution. So that's a very specific term. Basically, throughout the process of healing, the wound should go through three major processes. Obviously, there's sub-reactions and sub-processes. The first one is filling. So the extent of that process depends on the depth and the width of the wound. The bigger the wound, so to speak, the more feeling you're going to have, and most likely, by the way, you're going to have a scar. Clean cuts, smaller cuts usually heal better and faster. And I'll just say, by the way, the presentation doesn't actually emphasize that, but age is a factor. Our ability to heal lessens with time. Sealing means that you want to coat the area with some kind of materials that make sure that the wound is not open again. And once you have achieved sealing of the area, by the way, that also prevents further inflammation. Wounds attract inflammations by definition. So a wound is also a very promising, so to speak, environment for inflammations, especially by bacteria, fungi, and viruses. The explanation to that, by the way, is the factors, the healing factors. They are very potent, if you remember, and that attracts threats. And the last process is shrinking, meaning that with time you decrease the wound. Shrinking also connects it structurally and makes it more stable, and of course decreases the area that is exposed to threats from the outside, and it's an important factor. When we're talking about scars also tend to shrink, and if it's a major scar, it will actually elevate the tension in that area. Basically, the presentation talks about primary versus secondary intention. We all should wish to have primary intention occur. I'll just say this, both of them might lead to remodeling of the tissue. One of the most, I don't know if it's the most known result, but it's definitely very important and relevant to our course and to our profession, is remodeling of cardiac tissue after a heart attack. And when you remodel something, it changes its structure. And if you remember in the first presentation, we talked about the connection the relation between structure and function. So obviously, changes to structure most likely result in changes to function. We're not done yet. The next point, which I think is important for us in the field to understand, is diabetes. Personally, I can tell you, I don't have diabetes, but personally, analyzing diabetes, I think it's one of the most awful diseases that there is. And in this unit, you get a glance of how bad it is. It causes infections. It causes infections to become chronic. It leads to dysfunction of the immune system. It impairs healing. It causes bleeding, and bleeding is a factor that enhances inflammation. It involves glucose. Now I want to stop and tell you something. From my studies, yes, I was a student too. You're not the only ones. Glucose is one of the worst substances on earth. Yes, it has its advantages, but in large amounts, it's horrific. Did you know that the weapon with a capital T of the immune system while attacking foreign bodies is glucose? It's a weapon. Obviously, once again, when it's regulated, when it's under control, it's awesome. But I want to tell you something. When you lose control over glucose levels, you're asking for it. Let's connect this to knowledge that I'm pretty sure that you've heard before. I'm positively sure. You know that we have a certain amount of carbs in the body. If you look at the total, you'll have about more or less 2 pounds. A bit more, by the way. It's 500 grams, right? Give or take a bit. What percentage of that is allowed to be free in the blood, in the plasma? 5 grams. That means that more or less 1% of the glucose that you have in your body at a given time, or carbs in a given time that are ready for metabolism in a way, are in the plasma. You do not want glucose unsupervised, uncontrolled, unregulated. Diabetes is a disorder, and by disorder this means that regulation and control, hemostasis, have been broken. That the major factor in it is glucose. Another thing I want to teach you in chemistry, when you have a combination of glucose, most carbs by the way, but glucose obviously, with protein, what we call glucose coating, nothing will separate them. So that is a process you do not want to happen. And the fact is that one of the major biomarkers of diabetes is what we call A1C, hemoglobin that has been coated by glucose and loses its function. So I hope that kind of connects things a bit. So yeah, that's very serious, and diabetes is not only about that. Obviously, when you have hemoglobin that is coated with glucose, the ability to deliver oxygen lessens, and that of course is a bad idea. So many diseases are worsened by hypoxia, low oxygen, and that's just a start. If you were to make a list of all the manifestations of diabetes, I think you'd look at it and start praying that you don't have it or don't get it. Medication. Obviously, people with diabetes are on medicine. Historically, up to a few decades ago, the principle of medicine was do no harm. With time, it was found that that is not possible. So it changed to do less harm. Notice, in both cases, harm is done. That's not the question. If you're looking for perfect medicine, it doesn't exist. It doesn't exist. The most simple way to explain and prove that is that 99.99% of medication at some point is going to go through the liver and perhaps the kidneys to be broken down, and then those two organs are affected. Liver is number one. The chances of your liver being damaged, not necessarily fatally, lethally, is very high. So sometimes a physician has to decide, okay, I'll give this medication, I know the liver is going to be damaged, or there might be side effects to other organs, but relatively to the other option, this is the best option, or the less worst option. Think about it. So just so you know. Obesity. One of the major topics in the center of our profession, obesity. Fat is a tissue that promotes inflammation and acts against the idea of healing, especially the process of shrinking. Sorry, I apologize. The process of sealing, but the mistake that I made is only half a mistake, because without sealing, shrinking will not occur. So wounds and inflammations tend to be worsened with people that are fat or obese, I should say. All right. Let's go back to the adaptive system. The adaptive system reaction is based on what we call clonal diversity. The word clonal means that we're talking about masses here, and once this system encounters a threat, gene expression of certain cells, obviously certain genes that lead to the production of certain proteins, hence the ability of white blood cells to attack, is increased greatly. We can also divide the system's response to active and passive. Active means that the host is initiating and has these abilities to defend, and passive means that you have to receive those abilities from a donor. I think that the classic example that I have also used in the presentation is the situation of pregnancy. Obviously, the fetus depends greatly on the mother to donate from her abilities, and some of those are immune abilities. A major issue with the adaptive system is what we call tolerance or immunotolerance. When you have immunotolerance, that means that the body is able to identify what we call self and foreign, or non-self. Self means that you're able to recognize yourself. That means that the immune system is not confused every time they meet a part of your body, a cell, tissue, factor. The immune system is able to understand that this should not be attacked. When you lose tolerance, that means that you are going to attack yourself. It might happen almost every day on a small scale, but when it happens on a large scale, it might develop to a disease, what we call autoimmune diseases, where the body actually attacks itself, and as always, it might end in death. When we're talking about the treatment that should be given, or the reaction that can be produced or induced by a threat, and obviously a disease that might be developed eventually, God forbid, it depends not only on the response but on the point of entry. So the point of entry, where did the threat come from? Where did it enter the body? Will obviously and naturally influence the symptoms. The symptoms in the respiratory system are not the same as the symptoms in the gastric system, but also the treatment. So there's a balance here. It's not just this or just that. It depends on multiple factors, as most things are. When you read the presentation, or when you read the book, I want you to remember one thing, and this is also I'm gonna say this also in regards to cancer when I upload that video. You read the presentation, it sounds like you're already diseased, but you're not. Diseases don't happen that much, and if it was so easy to develop a disease, most of us would be diseased. But that's not the situation. That's not reality, meaning that there are many factors, many conditions that have to occur at the same time. And perhaps by doing this, you understand that the threat has to succeed in what it wants to do, and the body has to fail at preventing that in order for a disease to occur. So it's not that easy. It's not that easy. And yet it happens. So for inflammations to become chronic, for threats of different kinds, bacteria, fungi, viruses to succeed, there are many things that have to go wrong on our side, and almost equally many things that have to go right on the attacker side, and only when the perfect conditions are met, then you're diseased. So it's not going to happen that fast. Excuse me. Let's look at the attacker's side of the story. You have an organism that, while it opposes a threat to us, it just wants to live. And I'm not saying by that we're not supposed to attack it. Obviously we are. But the ultimate goal of an organism is to survive. So it's natural for such organisms to develop mechanisms of defense for themselves. So one of them, and it's a major ability, here comes that word again, genetic switching, is the ability of an organism to display different surfaces. Now, since the adaptive system is very specific to the surface, if you can constantly change how you look, it's harder to find you and recognize you. Imagine, God forbid, that you want to avoid the police. You are wanted by the police. They have a photo of you, given around, passed around, and you don't have hair. Suddenly, within 3 days, you put on a wig, or you start growing your hair, or a beard. Well, at least the men. I don't advise that for the women, right? What you're doing is trying to look different. So genetic switching is exactly what threats do, organisms do to their surface in order to not be recognized. Very, very, very simple idea. Of course, it involves gene expression and gene changes that result in different proteins that are presented on their surface, and that confuses that might confuse the immune system. It will definitely delay the response. When we're talking about parasites, we're talking about organisms that take advantage of the host's ability. It can be from metabolism, and it can also just be by hiding within the cells. So if you enter a cell and you're not in the bloodstream anymore, the immune system is in the bloodstream, it doesn't see you, and you might be protected for a long time, or even for eternity. Another option is to suppress the immune system. So there are different factors that can be secreted, toxins that will cause the immune system to not function or lower its function, and then you improve your chances of surviving. Then we have what we call immunodeficiency. Once again, it's divided to genetically based immunosufficiency, so those would be mutations and changes to genes that lower your immune ability. And you have what we call acquired immunodeficiency, which I guess the best example would be AIDS. So that would be a virus that has entered the body and causes that immunodeficiency. If you noticed in the presentation, immunodeficiency is very specific, which is good, because the treatment can be very, very specific, and it also represents the idea that it's localized and confined to a certain kind of cell. Then the presentation discussed the idea of immunohypersensitivity. Obviously, those are examples of situations that the regulation and control are lost. The outcomes are 3: allergies, autoimmunity, and what we call alloimmunity. So allergies, we all know them. There are they bother you, they bug you, they can lead to severe outcomes, and then you have to avoid the allergens, which are the factors that create allergies. Autoimmunity, we talked about that. It leads to a situation where the immune system attacks itself because it does not recognize itself, meaning you have low immunotolerance. And alloimmunity means that the immune system will attack anything from another person. So that would affect your ability to get donations, So that can be tissue, organ transplants, and as we said, donations from mother to fetus, for instance. The last thing that we're going to talk about really shortly is stress. Stress is a defense mechanism. Once again, there's a difference between regulated and controlled stress and uncontrolled and unregulated stress. When they are not controlled, you see disordered, or when they're not regulated, you see disorders. So we definitely have stress disorders, which originate from what we call stressors. Stressors is anything that causes stress. Very simple. In the heart of the idea of stress, we have what we call the biological syndrome of stress, which is presented with physical components. You can see that glands are major factors in those physical components. The stressors affect CNS, the central nervous system. That leads to defensive mechanisms that obviously will include the immune system. We can talk about what we call condition responses. So any connection that your brain has made throughout your life, that the idea is that something means danger, leads to what we call condition responses. And anything can do that. It can be the dark, it can be a dog, it can be a snake, you name it. The response will be responses of stress. And one of the most known conditions responses is what we call PTSD. That is very common in general, but is greatly associated with military service. We can see combined reactions, meaning that reactions to stress are not only from one system, but many systems, and every system has its symptoms. We identify the HPA axis, which is a hormonal cascade that leads at the end to an immune response. We have the theory or the idea of PNI, which a key principle in there is identifying the role of personality in these responses. We have what we call the sickness syndrome, which is non-specific, meaning that a person is showing a lot of symptoms that are not specific to a certain outcome. We're talking about stress as a factor of the ability to cope with stressors or demands, and stress is actually the inability to cope with those demands. And at the very end, we're talking about allostatic load, which is the sum of stressors. So obviously, if you have a lot of things in your life that cause you stress, your allostatic load is going to be higher, and the results are going to be worse. One of the worst results of high allostatic load is structural remodeling of the brain, meaning that the structure has changed. You already know what's coming, right? The function will change, and it's not any kind of function, it's your brain. If there's an organ in the body you don't want to take on, it's your brain. So I hope this helps you. I will be sending and uploading a file breaking down the last quiz. explaining possible question options. Sorry, and I hope that helps you learn for those who are retaking the quiz, and if not, will probably help you for the next quiz. Have a great day. I'll see you around.